Yes. See, about the chemistry of these group 15 elements, let us see their reactions with hydrogen. General representation here is given. E means that element from that group 15, maybe nitrogen, maybe phosphorus, maybe arsenic, maybe antimony, maybe bismuth. And that element will react with hydrogen to give a hydride of the formula EH3. What this reaction signifies, that hydride formation. Hydride, IDE, means hydrogen is bearing negative charge. If hydrogen has to bear negative charge, then those relatively should be what? Electropositive. It remains a general understanding because if ID, but in general, whatever I'm talking about, a general representation. Here, which of the elements are there? Few are there, those are more electronegative, and few are there, those are less electronegative than hydrogen. Those who have metallic character are less electronegative than hydrogen, and those who have non-metallic character, those are more electronegative than hydrogen, whatever may be the situation. So general point of view, we are seeing that the compounds with hydrogen of this group 50 elements, we are seeing it as hydride. So if I say nitrogen as a one element, first element, nitrogen is more electronegative than the hydrogen, but there is a formation of the covalent bonding. When covalent bonding is there, then the compounds of hydrogen we can say as what? The hydride. If there would have been the ionic bonding, unless and until there is a negative charge on the hydrogen, we can't say it is what? The hydride. So because of covalent bonding, we are saying it is what? The hydride of nitrogen, or we say it is what? Ammonia, a common name that we are seeing. So reaction is very simple. The elements which remains in the elemental form in different forms. For example, nitrogen remains in what? The diatomic form, molecular form. Phosphorus as a entity formation. Generally we say elemental form is a P4, but atomic form will be P only, phosphorus. But P4 formation is considered. As like phosphorus, like well, arsenic also remains in what? The AS4 forms. As like two nitrogens combine and form an N2 as an element. Those are formed from two nitrogen atoms. And about antimony and bismuth, we can represent them in atomic way. Only phosphorus and arsenic, they remain in a cluster, 4 atoms to combine. About nitrogen, 2 atoms to combine. And antimony and bismuth in the elemental form we can consider as an atomic way. Though they are the metal, the atom can be separated. But if we consider nitrogen in elemental form, in occurs in a gaseous form, and it is a N2 form. That's elemental form. So many do have the confusion about the element and the atom. What they consider nitrogen N means atom and the same as what? Element. No. Elemental form means how it occurs elementally in a nature, traditionally or regularly. That form is its elemental form. About metal, metallic bonding is there, but atoms are combined together to form what? Metal. So individual entity, discrete entity is that atom. So sodium, if I would represent, I'll represent as Na. Potassium, if I would represent, I'll represent by only K. If I represent antimony, we'll represent it by what? Sb. If bismuth, then I'll represent it by Bi. So if metallic form, the atomic form with which we can represent. If it's gaseous form and diatomic, always gases are diatomic, not likewise, but majority are what? Diatomic. It depends upon the bonding. And about nitrogen, it is a diatomic. Therefore, elemental form nitrogen will represent N2. That's a chemical we can take. If I take phosphorus, then phosphorus, as like all phosphorus combined, though phosphorus from atoms is formed, but they remain cluster form. 4 phosphorus remain as one family, other 4 phosphorus other family. So among them the linkage remains, and the phosphorus as a material that you can find out. So while considering that the unique entity, we will consider it as what? P4. Similarly AS4. So accordingly only the balance of the reaction will be different. Otherwise the element plus hydrogen, they give the hydride. Hydride for nitrogen NH3, hydride for phosphorus PH3, for arsenic ASH3, for antimony SBH3, for bismuth BiH3. So 3 hydrogens are going to surround that the central atom of the group 15 to form the hydrides. Because of their elemental form variation, the reaction balancing is varying. I hope you will understand the balancing of that reaction. Now I ask you the question. See, if I see the nitrogen representation is N, If I see phosphorus, representation is P. If I see arsenic, representation is AS. You will understand that S also is there in that name arsenic. But if I say antimony, in that antimony S is not there, B also is not there. But then why the symbol for antimony is SB? Yes, can anybody answer? Last year I discussed this point and I had given the work to you also. Yeah, and you have done that work. Many students have done the work. You have to find the elements where names are different and you have answered also in the YouTube video. SB stands for what? Now, if you are giving answer in the chat box, I could not able to read that because I am presenting the screen, no?
Latin
Yeah,
word.
Shubham. Yeah, Latin word. Latin word, I agree. But what is that Latin word?
Stadium.
Exactly, Gitanjali is right. It is stibium. Because of stibium, name is SB. Okay, other names are what the common name. But everywhere you are finding three hydrogens are surrounding. And see their names. It's a ammonia, it's a common name. Second is phosphine, arsine, stibine. Yes, stibium came. If anybody has read the reaction, also could able to recognize that what Gitanjali has said. And bismuthine. These are the names of these hydrides. So these are the reactions to form the hydrides of group 15 elements. Now let us talk about their various properties. The first property is about stability. The stability of these hydrides decreases from ammonia, that's a hydride of nitrogen, to bismuthine, hydride of bismuth. Why it is so? It is because a central element or atom that we are considering as E, its atomic size increases. Means right from nitrogen, if I come down to bismuth, atomic size will increase. If atomic size increases, means nucleus remains away from the coming atom. This nucleus should attract electrons of the other, no? Or proper overlap should be there. And because of that bulgierness, largerness of the atom, the distance between the nucleus of that element, say bismuth, and hydrogen will increase. In case of nitrogen, nitrogen is smaller, hydrogen is also small one. Everywhere hydrogen is there. So distance between nitrogen and hydrogen is small in case of NH3. But if I go down, then distance will increase, separation will increase. It is because of atomic size. And if separation increases, then bond strength will decrease. If bond strength decreases, then easy breaking of the bond possible or stability will be less. So what is the reason of the decrease in the stability as we move from top to bottom? It is the atomic size of the central atom. So here with the diagram, it is given there. See atomic sizes. Nitrogen atomic size is 70 picometer, while bismuth 148 picometer. So as we go down, size increases. Accordingly, stability of these hydrides, which are those ammonia, phosphine, arsine, stibine, and bismuthine, will decrease. And for that, the bond dissociation energy, enthalpy change, enthalpy needed to break the bond in those respective hydrides. What are we finding in case of ammonia? It is 389 kilojoule per mole. It is the highest in that family, nitrogen family. While if you come to stibium, it is a 255 kilojoule per mole. It is less compared to 389. It is decreasing. But pay attention to its last hydride. What you are finding? It is thermally unstable. Means at room temperature also, at very low energy also, it is not able to find. So if we have to establish hydride of bismuth, then considerable low temperature is what necessary. Just let me see who wanted to enter. Saira Banu. Okay. So what is the conclusion? Stability of hydrides is decreasing as we move from top to bottom. Stability of hydride decreases because atomic size increases. With increase in atomic size, distance increases. Covalent bonding strength decreases. Overlap, effective overlap, I'm saying, effective overlap decreases. And because of that, stability decreases. Yes, students, now you have to reply, unmute and talk. Is my point of discussion clear? First, I discuss about the formation of these hydrides, all hydrides, their names, their composition. And now I'm discussing their properties. And in that property, first point is stability. Stability decreases. I move from top to bottom. Reason for that also I explained. One is atomic size and other is a less quantity of overlap or less covalent character. Is the concept clear?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay, very good. Yes. Now the point is reducing character. These hydrides are strong reducing agents. The reducing agent means they themselves undergo oxidation, and reducing character of these hydrides increases. See, previous option was decrease, previous conclusion was decrease. Now this reducing character is reducing character increases as we move from top to bottom, means from ammonia to bismuthine. Means bismuthine is the strongest reducing agent, or arsenite is a strong reducing agent compared to ammonia. Now we'll discuss what may be the reason for that. The reason is due to decrease in the strength of EH bond. Why for the reducing agent? Because they can provide hydrogen, they can supply hydrogen, and then that hydrogen can undergo the oxidation, so that will be the reducing agent. So the source of hydrogen is with these hydrides, because these hydrides are with hydrogen linked to the central atom, and because of the availability of hydrogen, these are reducing agents. In true sense, what happens? Who is reducing agent? Reducing agent is that chemical who itself work or itself undergoes oxidation. Oxidation means it can give the electron. Who can give electron here? Hydrogen can give the electron here. To whom? Any species of whom we are doing reduction. Then where hydrogen will be easily available? In those hydrides where bond is weak. Bond is weak, hydrogen can easily come out. If hydrogen comes out easily, reduction can occur easily. So reducing ability of bismuthine is largest compared to ammonia. It is a conclusion. It is because of the decrease in the bond strength between the central element, central atom, that's a hidden element, and the hydrogen. Yes, is that point clear about reducing property?
Yes, sir.
Yes, sir.
Okay, now pay attention. Next point, basic nature. These hydrides are basic in nature. Basic means acidic basic of that category. They are Lewis acids due to availability of lone pair of electrons on the central atom. See, I discussed that point. The Lewis acid strength, the BF3, BCl3, BBr3 and BH3, we compared their Lewis acid strength. Now we are discussing their basic nature in terms of Lewis concept. Who will be the Lewis base? Who can be the lone pair? And these elements, 15 group elements, in their hydride form, they have the lone pairs. For example, ammonia, nitrogen in the ammonia has one lone pair, and that lone pair is donatable. Lone pair can be shared with whom? The Lewis acid, so that the bonding is possible. Lewis acid means what? Who can take that the lone pair. So these elements are there, they are with lone pair. Now you have to answer the question. As I move from nitrogen to bismuth, what do you think? Where will readily lone pair be available, at nitrogen or at bismuth? What do you think? What is your guess? Answer is there in front of you. Who can give readily or easily that lone pair? Nitrogen or bismuth? Now you have to reply, unmute and talk. Students waiting for your reply. If don't know, then say don't know. Unmute and talk. I'm not understanding what is happening. Are you understanding my question?
Repeat, sir.
Okay, listen carefully. I'm talking about the basic nature. Basic nature is due to the lone pair present on this atom of the central, these 15 elements. So nitrogen is the first element and bismuth is the last element. My question is, who can give lone pair easily? Nitrogen from ammonia or bismuth from bismuthine? Who can give lone pair? That's my question. And answer is there in front of you on the screen. Let me see what is happening here. Now, what's the answer?
Bismuth.
Bismuth.
Shubham is saying bismuth. Okay, good. Yes, here is the problem. Generally, what you think, we think on the form of electronegativity. In the point of electronegativity, nitrogen is more negative, so it will not give the electron. It is not. It is a concept of lone pair. It is different one. What happens here? Nitrogen is small and nitrogen has one lone pair. Similarly, bismuth is large and bismuth has one lone pair. So that other at bonds are there, bond pairs are there, they will repel. Repulsion is there in case of nitrogen more. So tendency of nitrogen in ammonia is more to give electron, that's a lone pair, rather than bismuthine, because bismuthine is larger size. Hydrogens also are considerably separate. So let the lone pair be. Lone pair is not a load for that the bismuth, but for nitrogen, that lone pair is a load. Why? That is negative charge, and that negative charge and other nitrogen hydrogen bonds, there also electrons are there, no? The repulsion is there. So because of that, nitrogen tends to give lone pair more readily than bismuth. Whatever answers you have given now, 2-3 students are there, they have given the answer. What they might have thought? They might have thought on the category or on the point of electronegativity, which is not applicable here. Despite of high electronegativity of nitrogen, the nitrogen in ammonia is a good donor compared to bismuth. Therefore, basic character will decrease as we move from here. The answer is given here. The basic character decreases down the group with increase in size of the central atom. So lowest hydride, so bismuth hydride or bismuthine, is a weak Lewis base compared to nitrogen hydride or ammonia. So basic nature decreases. Is that point clear?
Yes, sir.
Yes, sir.
Okay. Now see boiling point. The boiling point of hydride decreases from ammonia to phosphine. There's a decrease in the boiling point, and then increase from phosphine to bismuthine. Trend is not regular. The same trend is observed for their melting points. Means whatever the reality is there, that is explained. Now I will discuss why such thing may possible. Means their physical constant. If I come from nitrogen to phosphorus, means ammonia to phosphine, there is a decrease in the melting point or what the boiling point. But suppose if I start from phosphine and go down, then I am finding what there is an increase in the physical constant. Now question arises why it is so. Can anybody answer? I'm talking about hydrides. I'm not talking about elements. Can anybody guess why it may be? Here bond strength is not important. Here bond strength between that the central element, that's a central atom, and the hydrogen. Okay, I help you. In case of ammonia and phosphine, relatively central atom is what smaller. So crowding, whatever we expect, that is expected to be what the more in case of the ammonia relative to what the phosphine. And because of that, the physical constant for the ammonia is larger, and for phosphine it is what smaller. But same logic is not applicable for others. There what happens, a non-bonding character of nitrogen phosphorus after it changes, then next element arsenic, there you will find the metalloid character, metal and non-metallic character. Metallic character is introduced there after phosphorus. If you consider antimony, if you consider bismuth, metallic character is more added, and because of the increase in metallic character of the central atom, of course, when the hydride forms, then the central atom, only one atom, metallic atom not there, the hydrogen are surrounding. So with the change in their nature, it become more electropositive, you know? And if it becomes more electropositive, hydrogen will become negative, hydride version. So there is a somewhat more ionic character. And because of that ionic character, one molecule, say BiH3 or SbH3 or ASH3, can hold the other molecule somewhat more tightly because charge separation, the charge formations are there. So one positive charge can attract the other negative charge. And because of that linkage, and their size also considerably larger. So there is a good attraction, there is a good affinity between the families, between the molecules, and due to which breaking their bond becomes difficult or the physical constants increases. I repeat, in case of ammonia and phosphine, covalent character is a major point. Covalent character is a major bond. Covalent characteristic is more responsible, and both are nitrogen and phosphorus are non-metals. Therefore, again the covalent character is there, and due to which between two molecules attraction is relatively less. But among ammonia and phosphine, in case of ammonia it is more because of small size. They are coming closer. In case of phosphine, because of large size, they are somewhat separate. And due to which what is happening, the physical constant, maybe boiling point or melting point, for phosphine is less compared to ammonia. But if I continue that now, from phosphine if I come to arsine, from arsine if I come to stibine, from stibine if I come to bismuthine, then trend is different. What we are finding, there is an increase in the physical constant. Why? Because here metallic character is there. Metallic character is increasing. Due to increase in metallic character, the tendency of central atom will be there to give electron, and hydrogen will take electron and will form hydride. So within the molecule, considerable charge separation is there, which was not there in the ammonia and phosphine. It was there, but to less extent. But here to a great extent it is there. And due to that, covalent bonding is there, but ionic character is increasing. Due to which positive negative. If one molecule is there where positive negative things are there. One family is there where positive negative aspects are there. Other family positive negative aspects are there. Then a bit natural, a negative aspect of this other family can attract the positive aspect of other. So there will be the interaction between the two molecules. So molecules will gather. There will be somewhat strong in bonding in case of the bismuthine, and due to which the physical constants are higher, but bond strength is different. And I'm talking about the intermolecular interaction. Intermolecular interaction is strong in case of the bismuthine, therefore physical constant is high. Yes, students, are you following what I'm saying? This point?
Yes, sir.
Yes, sir.
Okay, if I have to repeat, then say, because only 2 replies I found. Yes, any other reply for whom it is clear? If not clear, then say not clear. Yeah, I could not hear that. No, I'm not getting the answer. See, you have to reply. Otherwise, there is no mean to discuss here in the lecture. I should know, then we are coming live. See, I'm asking question to you. Is the concept of physical constant variation for these hydrides of group 15 clear to you?
Yes, sir.
Yes, sir. Yes, sir.
Okay. And in case if further problem comes further, we can ask later. Next is reactivity towards oxygen. This group 15 element can form 2 types of oxides. One, E2O3 and other E2O5. Now I want answer from you. What may be the oxidation state of E, mean that element, in E2O3? For example, Fe2O3 we say, no, in that way. Here Fe is not there. I'm talking about the elements in the group 15 element. E2O3 is a one form of these oxides. So E2O3 means what is the charge on E? Oxygen is more negative compared to them. So oxygen will certainly be the negative charge. So I'm asking charge on that E in E2O3. See, here I will not go next unless until you answer. If you don't know, then say don't know, I will explain. But don't reply. And reply should be there from each and every student. Without that, I am not going next.
Don't know, sir.
Okay, 1 reply I found.
Don't know, sir.
2 replies.
Don't know, sir.
3 replies. I am not counting messages in the text box.
Don't know, sir.
No, Saurabh already said. Repetition not allowed. Only 3 replies I found.
Don't know, sir.
Don't know, sir.
4, 5,
No, sir.
6.
Don't know, sir.
Further 4 replies I want. Only 6 students have replied. If you are replying here in text box, I am not counting that. You have to talk. Unmute and talk.
No, sir.
Okay, 7 replies. Further 3 replies I want.
No, sir.
Okay, Mandar, you have given already
Don't know,
reply.
sir.
Repetition not allowed. Okay, 8 replies. Further 2 replies I want. You are wasting time. Otherwise, chemistry will be difficult. See, understanding remains there in the science. Science grows the concept stepwise. Patience is necessary. Direct application you will not realize now, but afterwards you will understand, okay, because of that, these applications are there, or these are the true ways by which we can understand these molecules. At later on, we will understand, but before that, basic should be clear. Now, let me see. See, out of 14 students, only 10 have replied. Ganesh, why have you not replied? Ganesh, Gitanjali, Jelina has replied. Jonet, I think, not replied. Mandar replied. Nishan replied. Sahil replied. Saurabh replied.
Sir, I will reply.
Sir, I have.
You have replied. Okay, Jonita is there. Okay, replied.
Sir,
Shubham.
मी पण
Shubham Duri. Gitanjali, what happened?
सर रिप्लाय केलेला मी.
Okay. Maybe that because all are not coming on the screen, no? Only few are coming. Shivam Golame replied. Vasant Misha replied?
Yes, sir.
Yeah, okay. Maybe you are replying, but because I could able to 1, 2, 3, 4, 5, 6, 7, 8 only one time. Therefore, though you have replied and synergically maybe the replies were there, therefore the issues. Okay, fine. 1, 2 if are not there, possibility range function. Okay, now pay attention because basic things are to make clear. Firstly, I make the clear. When compounds form, then there is a take and give or gain and loss of electron, not perfect as such, or sharing of the electrons. And number of electrons to share, number of bonds to form, that depends upon electronic configuration. So base is electronic configuration. Now you only will answer for this question, but I will help you. Answer for my question. What's the atomic number of oxygen?
8.
No, I want answer from all. Otherwise, I'm not moving next. Now you can give answer in chat box. Will do.
8.
Okay, 2 answers only I got. I stop
8.
sharing so that I'll recognize all. Okay, 8. Yes. So if you see its electronic configuration in detail, 1s2, 2s2, 2p4. I hope you will understand. So in p orbitals, 4 electrons are there. In that sub-level, 4 electrons are there. And its capacity to accommodate is 6 electrons. But how many are there? 4 electrons are there. So natural tendency will be, answer from a question, it wants 6 electrons to fulfill, to have the full stomach, to have the stability. But it is with only 4 electrons, which outermost orbitals, outermost subshell, that's a 2p. So answer from a question, that oxygen will tend to take electron or will tend to give electron.
Take the electron.
Yeah, Shubham is saying
Take
take the
the
electron.
electron.
Yeah, Gitanjali is saying take the electrons. Saurabh also saying take the electron. Shilpa saying take the electron. Vasant saying it will take electron. Jelina saying take. Janeta, Gitanjali, Sahil, Nishant, Shubham. Yes, certainly. Absolutely, you are right. So it will take 2 electrons. Now answer from a question. By taking those 2 electrons, it will bear, it will govern who? Oxygen. Positive charge or negative charge. If it takes electron, then charge will be, ultimate charge will be positive or negative. Shilpa is answering negative. Shilpa's answer is negative. Only one answer. If somebody takes electron, what's the charge on electron? Negative, of course. By taking electron, that negative charge will be there. How much negative charge? How many electrons it has taken? 2 electrons. So how much negative charge will be there? In quantitative point of view, negative charge, -1, -2, -3, -4. How much minus? Yes, -2. So oxygen will bear or govern -2 charge. That will be the tendency of oxygen. It will take automatically because it's electronegative, so it will take negative charge. So keep in mind, charge on oxygen is -2, and other element can bear some charge. Which charge is there, that we have to find out from its formula. Now I explain you first one formula. Say CaO, calcium oxide, CaO. What is the charge on oxygen? You know that, -2. Then answer for a question, what should be the charge on calcium? If charge on oxygen is -2 and formula of compound is CaO, that CO has no charge, then what's the charge on calcium? Not Gitanjali, not -2 Gitanjali. Charge on calcium. Oxygen has -2 charge. To balance that, to counter that, charge on calcium will be +2. Yes, I hope you are getting this point. Very good, very good. Now, Al2O3, Al2O3, charge on oxygen -2. How many oxygens are there? 3. So total charge on oxygen -6. So that is to balance by whom? Aluminium. But how many aluminums are there in that formula? 2, because Al2O3. So positive charge should be +6 to balance that -6. And only 2 aluminums are there. Therefore, charge on aluminum should be +3. Now one more example I give you, this last example. Then I'll come to that question. FeO, ferrous oxide, charge on oxygen -2. So that is balanced by iron, that's Fe. So to balance -2, charge on Fe will be +2. So charge on Fe in FeO is +2. Is it clear what I say? Okay, now I am presenting the screen. Now if you give the answer in the chat box, I could not able to understand that. Here formula is E2O3. I am asking question to you, what may be the charge on E? E is an element from group 15.
+2.
Plus, say how many oxygens are there? What is the negative charge? To balance that, positive charge should be there. And how many such elements are there? Those can give the positive charge. E can give the positive charge. That's the application. If you could not apply here, means previous concept is not clear to you. Means you are saying yes, 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 means it is a false yes.
+3.
Okay, one answer is there, +3. I want at least 5 answers. There's only one answer now.
+3.
2 answers.
+3.
3,
+3.
4,
+3.
5. Very good. How you can find out, though, for whom it is not clear? See, oxygen carries -2 charge. So how many oxygen are 3? So total charge -2 into 3 -6. To balance the -6 charge, +6 charge should be there. Who can have positive charge? This E can have positive charge. And how many E are there? Only 2. So that +6 charge is to contribute by this 2. So charge on E is +3. So group 15 elements can show +3 as one of the oxidation state. Therefore, this is the formula. Other possibility, suppose because E2O5. Now I want answer from you. What can be the charge on E in E2O5?
+5.
Yes, only one answer.
+5.
+5.
2,
+5.
3.
5.
+5.
+5.
Okay. 4. Last. One more. I think combine your given. One more. Last answer I want.
+5.
Okay, fine. See, charge on oxygen is calculated -10 to balance that +10 on 2E. So charge on E will be the +2. Okay. Now the oxides of nitrogen in detail are discussed. Is a general way. It was the general way. But other than that, many possibilities are there. And here, see, oxygen. You have to work on this. Charge on nitrogen is +1, +2, +3, +4, +5. Many are possible. And if +1, then nitrous oxide, a laughing gas. +2, then nitric oxide. If +3, then dinitrogen trioxide. If +4, then dinitrogen tetroxide. If +5, then dinitrogen pentoxide. So these are the various oxides of nitrogen. Similarly, for phosphorus and for arsenic with their different charges, explanation is what given here. You can work on this and you will find that different oxides. Whatever the oxide is given, general statement is given, which is not perfectly correct one. Here, actual different oxides are what given. So up to oxides, you prepare the notes. So today, what I discussed, the chemistry of these compounds of these group elements. In that, first point was hydride, their reactions, stability, reducing character, their basic nature, their boiling point, and then reacted towards oxygen, general formation, and few compounds are discussed here, and you have to find their oxygen state. Then we will discuss next time this electronic configuration or inert pair effect that we will discuss. Yes, whatever I discussed today, is it clear that points or those points, notes you have to draw? That's the assignment for you. Is that assignment clear to you?
Yes, sir.
Yes. And this video I will publish at night. I'll see. Otherwise, maybe tomorrow night I'll finish that task. So shall I stop now?
Yes, sir.
Yes, sir.
Okay. Okay. Those who are completing assignments, their attendance will be considered. Communicate the message to your friends. And attendance, if you are not caring, then later on, if wherever the situation will be there, I will adhere on the point. Assignment is to complete. Without completion of assignments, no other. By any means, suppose practical exam is given to me, and if I have to check your journal, then without internal that work, you will not be allowed to submit that journal if it is given to me. No, you have to submit all. Nishant, if you submit it, then no problem. Everybody has to submit. Okay. I stop the recording and I say that today's session is over.